Good morning, ninth graders. I hope you all are doing well. Again, I apologize for not being able to be there for the next few days, but learning must continue. For the next few days, the sub will give you guided notes, and I will prepare you videos for you to fill in those guided notes. So anytime you feel like I'm going too fast and you need to slow down, you can always pause the video, or you can always rewind and then press play to continue. I want you to try your best to understand the notes and attempt the assignment. Feel free to ask the subs, ask Z's for help, post any question you have on Schoology, and throughout the day, if I get to it, I will try to answer it. Alright, so let's start. So turn to your table of contents. We are starting a whole new unit. We are on Unit 7, and we're talking about polynomials. Today we'll be in 7-5, Polynomials Day 1. Alright, so let's go to your notes. So our title again is 7-5, Polynomials Day 1. Today is the 13th. So today the objective will be, I will be able to find the degree of a monomial, M-O-N-O-M-I-A-L, and polynomials, P-O-L-Y-N-O-M-I-A-L. So again, I will be able to find the degree of a monomial and polynomial. You might be thinking, what in the world is a monomial and a polynomial? Well, let's just start off by talking about what a monomial is. Well, a monomial is a number of a variable, right? Product. Remember, product just means multiplication of numbers and variables with whole number exponents. So again, just a reminder, if I'm going too fast, please pause the video, copy the notes, and then press play to continue. So let's look at some example of what a monomial is. So for example, a number, so like number 5, that is a monomial. Something like a variable like x by itself is also a monomial. Or a product, so something like -7 x times y, that is also a monomial. Or something raised to an exponent, like if you have 0.5x to the power of 4. So again, you can see we have a number that will represent a monomial, a variable that's also a monomial, a product means -7 is multiplied by x and multiplied by y, that is also a monomial, or a number multiplied by a variable raised to a whole number exponent, that is also a monomial. So let's look at a few examples that are not monomials. So an example of not a monomial will be something like -0.3x to the -2 power. The -2 power makes it not a monomial because -2 is not a whole number. -2 represents an integer, which is not a whole number. We can have something like 4x minus y. This is not a monomial because of the minus sign. Monomial can only be a single term, like just a number, just a variable, just a whole term with products, or a term with just a exponent. We cannot have any addition or subtraction or anything between the two monomials here. So 4x minus y is not a monomial because of the minus sign. Another example that is not a monomial will be something like 2 over x to the third power. Because we have a fraction, or in this case you can call this division, that will make it not a monomial as well too. So again, a monomial is a number, a variable, or a product of numbers and variables with whole number exponents. Not negatives, but whole numbers. Alright, I'm going to list a few terms on the bottom here. On the bottom where it says circle the monomials. And I want you to take a minute, pause the video after I write this out, and see if you can circle the monomials. And then press play and see if you circle the correct ones. Alright, so I have 9x squared, 2x to the 4th power plus 3, negative 9yz to the 4th power, 2x to the negative 2nd power, or 2 over x. So pause the video for just a minute. I want you to try your best and circle the monomials, and then press play and then see if you circled the same one I did. Alright, welcome back. Hopefully you circled 9x squared, negative 9yz to the 4th. And that's it, because 2x to the 4th power plus 3 is not a monomial because of the plus sign. 2x to the negative 2nd power is not a monomial because of the negative 2. It's not a whole number. 2 over x is not a monomial because of the fraction sign here. So that left us with just a number, a variable to a whole number power, and a product here raised to a whole number power. So when we talk about a monomial, we want to talk about a characteristics that they have. And that characteristic is the degree of a monomial. And all that means is the sum, and if you forgot what that means, it just means add the sum of the exponents in the monomial. Alright, so let's do a few examples. I'll do the first one, and I'll have you guys try the second two. So let's say we have something like negative 2a to the 3rd power and b. What is the degree of this monomial? Well, if we look back in the definition, it says the degree of a monomial is the sum of the exponents in the monomial. So in this case, anytime we look at a monomial, we know that there's this negative 2 has a power of 1, but we're not going to include that in here. So when we talk about monomial, we're not going to look at the constant or that number. We will only look at the variables. So in this case, we have a power of 3 with the a, and the b is raised to a power of 1. So it's always to a power of 1 if there's nothing in that power section. So to find the degree of this monomial, so degree, all you do is 3 plus 1 equals to 4. So the degree of negative 2a to the 3rd power, b to the 1st power is 4. The degree of this monomial is 4. Alright, so I'm going to write down 2 examples, and then I want you to pause the video and then try it and check the answer with mine. Alright, so example 2 is 8yx, and example 3 is just a number 10. So take a minute to pause the video, try it out, and then check with my answers. Alright, welcome back. So example 2, you should have saw that y and x doesn't have a power, or it's not written, so we know that it's a 1 on top. So the degree for 8yx would be 1 plus 1, which equals 2. So the degree for 8y to the 1st power, x to the 1st power, is 2. Example 3, as you can see, all we have is just 10 with no variables. So here remember example 1, So we're not going to include the exponent from the constant, and since 10 is a constant, we can't include the power from the constant. And since we have no variables with a 10 here, we have no degrees. So this would be degree 0. So anytime you have just a constant or just a number with no variables, your degree will be 0. Alright, so I hope that made some sense, and hopefully you understand how to find or distinguish what is a monomial, or how to find the degree of a monomial. Let's move on to a polynomial, the second part of the lesson here. So let me go back up just a second before we go to polynomial. Let's look at the word monomial one more time. I forgot to show you this, but if it helps, the word monomial, you see the word M-O-N-O, mono. Mono just means one. You'll hear people say monotone, or any other words that has the word mono in front. That just means it's singular. That's one of that thing. So as you can see here, we have just one piece here with no addition or subtraction, one piece with no addition or subtraction or division. So again, mono just means one. So let's go down to polynomials. As you can see, the word there's poly, P-O-L-Y. Poly means more than one. For example, the word polygon, it has the word poly in there, meaning more than one side. Alright, but let's get back to the definition of a polynomial. A polynomial is a monomial, M-O-N-O-M-I-A-L, or a sum or difference of monomials. Alright, so let me give you an example. So we know that this is a monomial, 4x is a monomial, and if we say minus 18x to the fifth, individually 4x is a monomial, and individually 18x to the fifth is a monomial. If you subtract them, they become a polynomial because they have one monomial term, two monomial terms together with a subtraction sign, so they have two terms. So this makes it a polynomial. Let me show you another example. Let's say if we have 15y plus 6z, that is also a polynomial because we have one individual monomial and another individual monomial. With the plus sign, combining the two together makes it a polynomial. So just like a monomial, one important characteristics we need to find for a polynomial is their degrees. So the degree of a polynomial is the degree of the term with the greatest degree. The greatest degree. So again, I'll do one example, and I'll have you guys try the next two examples. Alright, let's say we have 4x minus 12x to the 7th power. What I would do is write each individual monomial down and find their degrees, and then choose which one has the highest degrees. For example, we can say 4x has a degree of 1 because x is raised to the first power. Negative 12x to the 7th power has degree 7 because x is raised to the 7th power. So the degree for this polynomial is degree 7 because 7 is the highest power from this polynomial, 4x minus 12x to the 7th power. So all you do is find the greatest degree from the polynomial. So let me write two examples down and have you try it and then check with my answers. Alright, so take a moment to try example 2. 6x to the 4th power plus 9x to the 2nd power minus 7x, minus x minus 4. And example 3, 5x to the 2nd power times y plus 0.5x times y plus 0.7. So pause the video for a minute and try these last 2 examples. Alright, so welcome back. Hopefully you give that a shot. So if you were to list your your monomials out, you would have got 6x to the 4th power, which is degree 4, 9x to the 2nd power, which is degree 2, and negative x, which would have been a degree 1, because it's to the 1st power. And lastly, negative 4 is just a constant, so it has a degree of 0. So if we look at all of this, the biggest degree here is degree 4. So the polynomial of 6x to the 4th power plus 9x squared minus x minus 4 has a degree of 4. Alright, so for example 3, let's list out all of the monomials. So you would have gotten, if you list out 5x squared plus 5x squared times y to the power 1. If you add 2 plus 1, you would have got degree 3. The next term would have been 0.5x to the 1st power times y to the 1st power. And if you add 1 plus 1, you would have got degree 2. And 0.7 is just a constant with no variable, so your degree will be 0. If you look at all of this, degree 3, degree 2, and degree 0, the biggest degree we have is degree 3. So the polynomial 5x squared y plus 0.5xy plus 0.7 has a degree of 3. So that concludes the lesson for today. I will check your notes on Thursday when I come back to give you points for taking the notes. So right now, please give it the homework a shot. Try your best on it. Come back and look at the video for all of the examples and see if it helps you understand how to find the degree of the polynomials and monomials. Thank you and have a great day, and I'll see you guys tomorrow for the next lesson. And then I hope to see you guys back on Thursday. Have a great day. Bye-bye.